Hello, and thank you for joining us for today's webinar. My name is Neil Foley, and I'm the Applications Engineer here at RISE. And today I'm going to be talking about how Additive Labs can use the technology and the capabilities offered by RISE to expand the different things that they're capable of and achieve the goals of their companies more effectively. So the first thing I'll do is talk about some of the challenges that Additive Labs in particular face. So one of those challenges is that they often have to serve a variety of different functions within their company, which means that they need to be capable of providing a variety of different materials as well as different approaches to printing. Maybe they need to be able to use large parts, or they need to be able to produce very high surface qualities, things like that. Another challenge that Additive Labs will face is that they need to be able to turn around part requests and deliveries very quickly, especially in cases where a request is urgent. Sometimes it may have a deadline as soon as a single day, and Additive Labs that are able to meet requests like that will be much more effective. Another challenge is being able to maximize throughput and efficiency. This applies in particular to large orders or cases where many orders come in all at once, and the labs will have to be able to handle all of those at once and be able to organize those onto their printers and get them out the door as quickly as possible. Another challenge is being able to track the requests from the many internal clients that are requesting parts, and also being able to track the different versions or iterations of a single part that may be requested. And there are a variety of different approaches to this, some of them more efficient than others, and RISE has one solution that can be quite effective. Another challenge faced by Additive Labs is being able to manage the space and infrastructure requirements of their labs. So in particular, this will apply to smaller Additive Labs that need to be able to fill out their capability requirements, but don't have the room to have a whole different set of printers where each printer is capable of a small set of things. It's better if they're able to conserve space and make sure that the printers that they have in their lab are able to accomplish a wider variety of different requirements. Also, regarding infrastructure, many additive manufacturing machines, 3D printers, will require venting or tanks for dissolving support, and these apply a sort of safety requirement that can be quite expensive and also use up additional space. So these are the different challenges that Additive Labs in particular will face. So now I'll talk a bit about the RISE platform and what we're able to do in terms of addressing some of these challenges. So more generally, some of the things that RISE is capable of doing is the color and carbon printing. So we're able to print parts in full color. We're also able to produce parts with chopped carbon fiber infusions, and this makes the carbon fiber makes the parts stronger and stiffer, and also have a higher quality surface finish. The full color prints can be produced on our new X-Rise machine, which can produce colors using a combination of different marking inks that will combine to create a full spectrum. Another capability that RISE has maximized is our speed and simplicity. We jet a release ink between support and model layers, and because of this, you don't need to have any special equipment in order to remove support. You don't need to dissolve it. You don't need to blow the material out of it. All you need to do is peel the supports off by separating the interface between the support and model structures. We've also put a lot of work into simplifying the pre-processing step, which pertains to our proprietary software, which is heavily automated. So you don't need to be an expert necessarily in 3D printing in order to use the software effectively. Also, our proprietary material, Rysium 1, has very good strength, particularly in the Z direction, and this makes it useful in a lot of applications that would be more challenging for other 3D printing materials to accomplish. One of the other capabilities of RISE is producing intelligent parts, and we do this using the marking capability, which allows you to apply barcodes and QR codes and various other markings that can connect parts to digital locations or digital information. And finally, some of the material properties of Rysium make it much safer than many of the other 3D printing polymers that you would encounter. So next I'll talk about the basic system that we use to accomplish these things. So RISE uses a patented technology called augmented polymer deposition, wherein between layers of extruded thermoplastic, we are able to jet different functional inks. So typically the way this will work is that initially a bottom layer or layers of thermoplastic support is extruded, and then on top of that we jet first a release agent, and then we print more layers of thermoplastic for the part structure, and then between those layers we will jet different marking inks. So in this image there are different colors shown for different types of marking inks printed into the part. And this capability allows us to accomplish a variety of different things. You can see the parts here use the marking ink in monochrome to apply part numbers, version numbers, and QR codes, which can be scanned to connect to a much larger set of information. A QR code connected to a web address is able to hold a virtually unlimited amount of information. It would just be limited by whatever you can fit onto the web page that you are linking to. So I'm going to show a quick video here of the way this QR code works. Link pops up, and in this case, it links to a page that shows information about the part. This can include the date it was made, the author of the part, the specifications of the part, maybe some things about dimensions or tolerances, all sorts of things like that. So now I'll talk a bit about our main material, Rysium 1. This is a engineering or medical grade thermoplastic. It is perfectly safe for skin and food contact. It has a lot of useful properties, as I've mentioned. One of those is that it has negligible moisture absorption. It is about 1% as much as ABS absorbs. It's also clean. You can throw it right into a recycling bin. You don't have to worry about any special process for recycling it or handling it. It also, because of the fact that its extrusion temperature is much lower than its decomposition temperature, we're able to extrude with no production of harmful chemicals, no production of volatile organic compounds. And because of this, the RISE machines don't require any venting whatsoever. And so this page goes into a bit more detail on that point. So the the Georgia Institute of Technology found over the course of a 2-year study that typical thermoplastic extrusion 3D printers will produce upwards of 200 different volatile organic compounds, including irritants and carcinogens in their printers while they print. And this can be quite harmful, particularly if those printers are not properly vented, which in some cases can require some expensive equipment and infrastructure. So what Rise does differently, as I mentioned, is that we don't produce any VOCs as we print. As I mentioned, our ingredients are all medical grade. They are skin and food contact safe, and the material is totally recyclable. And it also recently won an award for best practices in technology innovation in the zero emission polymer material additive manufacturing industry. So now I'll go into a bit more detail on some of the points I mentioned earlier. Some of the factors that make the Rise machines especially easy to use and to achieve a high turnaround of part requests is that they require very little pre and post processing. So our software is highly automated. You don't need to spend a lot of time preparing parts. You can generally throw the part into the software, hit prepare job, and it will be ready to be sent to the printer just like that. Also, the printer itself is quite easy to use. There's very little material management. There's a very intuitive user interface, and because of this, it can be very easy to pick up how to use it and be able to maintain it without a lot of equipment and without a lot of expertise required. Some of the other useful factors are, as I mentioned, because of the release agents, we are able to rapidly remove the supports by hand, and this can shorten the post-processing phase of creating these parts to almost nothing. So in many cases, a single part could be produced and delivered within a day, or even multiple iterations could be produced and delivered within a day. So because the support comes off so easily, you don't have to worry about soaking or washing or drying or cleaning or coating or anything else like that. There are a few things that you can do in post-processing to get sort of special effects out of the part, but those are typically not necessary, and generally all it takes is a few minutes or even a few seconds to have a part ready to go after it comes out of the printer. So here are some of the different applications that Rise parts have been used for. There are scale models, there are functional prototypes that can be produced in full color. Another useful one is casting molds, which can produce elastomeric parts. Some of the other factors, some of the other features of the Rhisium material include that it is very chemically resistant, and it also has a low surface energy, and because of this it can be quite effective for use in elastomeric molds because the material that is molded peels away very easily, and the mold can quickly be reused without a lot of post-processing after producing the molded part. Some of the other things that Rise parts have been used for include tooling and manufacturing for various applications, as well as service parts or end-use parts, which are useful for either creating replacements when parts break, or for similar to tooling and manufacturing, creating parts that you'll be using directly in the manufacturing environment. So now regarding X-Rise, some of the specific applications that full color prints can be used for include engineering applications for visualizing simulations or things like that, as well as geography, geology, and architecture, where we're able to print high resolution maps with both geographic data as well as sort of the political data, the names of different places. It's also useful in life sciences, where full color can differentiate among different organs and illustrate properties quite effectively. And it's also useful for product design or prototyping as shown here in the case of packaging. So here is a case study of one additive lab that has been using the Rise 1 for some time, and some of the greatest values that they've found in using the Rise machine is the usefulness of the marking ink, which allows them to easily trace parts and the requests that they receive. Some of the material properties that they've found quite useful include the negligible moisture absorption, as well as the low surface energy, which makes it, as I mentioned, very easy to release molded parts from printed molds. So you can see on the right here, there is a printed mold that is able to produce the tool in the back in blue by molding silicone around that handle. So now, just as a review, some of the features offered by the X-Rise that can be quite useful to additive labs include the differentiation offered by color and carbon capabilities that are all offered on a single machine, the X-Rise. Also, the speed offered by our minimal pre and post processing allows parts to be produced and delivered much faster than other technologies. Our strength is quite high, especially compared to other thermoplastic extrusion technologies in the Z-axis, and because of this, we are capable of performing effectively in a wider variety of strength critical applications. We also have the ability to produce intelligent parts, especially with QR codes, which allows you to easily track the parts that are requested and where they're coming from, and the iterations, and all sorts of other information like that. And finally, it is affordable because it has a low cost of operation, especially regarding labor costs and infrastructure costs, because you don't need a lot of external equipment, whereas you may need external equipment for other machines for post-processing and things like that. And you also don't need much labor because of how simple the pre and post-processing steps are. And finally, we do have a special offer going on right now where with each purchase of a Rise 3D printer, one license of SolidWorks design software will be included. So that's all I have for you today. Thank you for joining us for this webinar. If you have any questions, I will be sticking around for a few minutes. You can type them into the GoToMeeting chat window, and I'll be answering them. If you have any off-topic questions or you think of anything in the future, you can send those to applications at rise3d.com, and I'll be happy to answer those. So thank you again for joining us. I'll wait for a few minutes now to see if there are any questions.